This is geometry, 8.2. We are talking about the Pythagorean theorem. A lot of times the Pythagorean theorem is phrased as a squared plus b squared equals c squared. That's one way to think about the Pythagorean theorem. It goes in alphabetical order. All the letters are squared. But it gets a little confusing. And in a later part of our lesson, it's actually more beneficial to have the c in front. So we like to talk about it as c squared equals a squared plus b squared. Just to get in the habit of always putting this larger number first. Because the hypotenuse is always a larger number. In a right triangle, Pythagorean theorem only works with the right triangle. The square of the length of the hypotenuse is equal to the sum of the squares of the legs. So the hypotenuse squared equals the sum of the legs squared. Now, when you're using these letters, A, B's, and C's, it gets a little confusing when you come down here and you're solving for x. Which one's x? So it might be better for you to focus on it as hypotenuse squared equals leg squared plus leg squared, and not worry about the A, B's, and C's. Across from the 90-degree angle is always the hypotenuse. And the two perpendicular sides are always the legs. The perpendicular sides are the legs. So when we come over here, we're looking at the right angle. Across from the right angle is the hypotenuse. That's our 10. The perpendicular sides would be considered the legs. So I would encourage you to label your triangles. Identify which is which, because that's the common mistake people have. They put the numbers in the wrong spot of the formula, and it doesn't work out. Hypotenuse squared equals leg squared plus leg squared. That's our formula for the Pythagorean theorem. When you're trying to solve for one side of a right triangle, you can use Pythagorean theorem. So this is 10, this is 5, and this is x. The hypotenuse squared equals leg squared plus leg squared. It doesn't matter what order of the legs you go in. X squared plus 5 squared or 5 squared plus x squared. That's just fine. So we square the 10 to get 100. We square the 25, or the 5 actually, to get 25. You probably don't need a calculator for that. Now in terms of solving the algebra, we need to subtract the 25 across, and that gives us 75. Now look at what we have. We have 75 equals x squared. So pay attention to why and what we're doing. We have x squared. We need to get rid of the square. We just want to know what x is. Square means that we're saying x times x is 75. We want to know what just the number is. So take the square root and take the square root. When you square a square root, when you take the square root of something squared, you get that value of x. Now we have 75. How does 75 break down? What number goes into 75? Some people, because it ends in a 5, you might say that it's 5. 5 goes into 75. That would be one way to do it. Some people might say, well, if it was 75 cents, I know 25 cents goes into it. That's a great way to do it also. So either way you think about it. 3 times 25. Then you know the square root of 25. So your answer is 5 root 3. You could have called it 5 times 15. And 15 is 3 times 5. There's your pair of the same numbers. So if you have a pair of the same numbers, I like to circle those pairs of the same number. If you have a pair of the same numbers, you pull it out, and you have the root 3 still inside, and you'll get the same answer, 5 root 3. Notice this answer has a square root with it. We call that a radical. So this is simplest radical form. This is definitely not a decimal. And in the future, you're going to see directions that say simplest radical form. And that'll tell you if you should be using your calculator to answer it with a decimal. Let's try this one. Take a look. What's different about this question compared to that question? Across from the 90 is the hypotenuse. So the x this time is the hypotenuse. Your unknown side is the hypotenuse. The other two sides are the legs. So if we use hypotenuse squared equals leg squared plus leg squared, the hypotenuse has the x. So only if the unknown is the hypotenuse do you put the x first. You put the x in the hypotenuse spot only if the hypotenuse is your unknown. Then we have 15 squared and we have 36 squared. 15 squared is 225. 36 times 36 is 1296. When you add those two numbers together, you get 1521. Now, there's a couple different ways we could break this one down. But if you have 1521, and if you're using a calculator, if you're using 1521, it might be worth typing it in your calculator and seeing if, oh my goodness, it works. Saves you a lot of simplifying. So the answer is 39. Because you took the square root to get rid of the square. 39 times 39 would be, so x has to be 39. When you take the square root of both sides, 39 is our value. We've talked about how to break things apart if needed. Let's come on down and talk about area. Area of a triangle. Well, the height and the base of a triangle are perpendicular. So here, the height is straight up and down, the base is right to left. They're perpendicular to each other. Not just any perpendicular to each other, but if you take a look, from this point, it's equal distance to both ends. So this is a perpendicular bisector of this triangle. So I know it's 36 on this side and 36 on that side. So for me to calculate the area, the formula for area is A equals 1/2 base times the height. I know what the total base is. The total base is 72. I just don't know what the height is. Now what gets kind of tricky with these is that you have to break this triangle apart. You don't need to look at all that busyness. You just need to look at one portion of it. 39 is the hypotenuse, 36 is the leg, and we're looking for the other leg, which is the height of the triangle. So because the 39 is across from the right angle, this is hypotenuse, and that'll be squared, plus leg squared, just say leg, and this side is a leg. So we'll use our formula, hypotenuse squared equals leg squared plus leg squared, because that's the Pythagorean theorem. We're looking for one side of a right triangle. The hypotenuse, we've decided, was 39. The leg is 36, and our unknown is h. So 39 squared is 1521. Thirty-six times 36 was 1296. And we get 225 by subtracting across the 1296. Now what do I have to do from here? You need to take the square root of both sides of an equal sign. So we should probably say it. When you take the square root of both sides of an equal sign, you should get plus or minus. But because this is geometry and we're talking about a length can't be negative. A length is a positive value. So we're not going to consider the negative being a possibility. But in terms of your future classes, you would need plus or minus 15 in that spot. But for our terms and purposes, it's just a positive 15. So if the height is 15, we can now find the area. Area equals half the base times the height. Now you can multiply the 72 and the 15 together, or you could take half of the 72. And multiply those two together. 36 times 15. We get 540. And those are miles squared, or square miles. 540. Okay, so to finish up, this is an important one because this one makes decisions about how you handle a problem. Here are the methods for classifying a triangle by the angles. So is it obtuse triangle? Is it an acute triangle? Is it a right triangle? Those are the three options. And we're going to be using the side lengths to help determine that. So if we do c squared, a squared, and b squared, and a squared plus b squared equals c squared, if it equals it, then we're going to have what we've been using. We're going to have a right triangle. But where things get interesting is what if the c squared is smaller than the a squared and b squared? What if the c squared gives you a smaller number than if you add the a squared and b squared together? In this case, the a squared and b squared equaled what the c squared was. But here we're saying that it's smaller. C squared is smaller. Smaller would be acute. So that's why it's important to put the c squared first so you can read it in that format. C squared is less than. Less than would be small. Less than would be acute. Acute triangle. You don't want to read it the other way and say that a squared plus b squared is greater than c squared, because greater than usually doesn't imply something small, like an acute triangle. Over here, the other option is that c squared is greater than the sum of a squared plus b squared. In those cases, you're going to have an obtuse triangle. Remember, an obtuse triangle has an angle that's bigger than 90. Acute triangle has three angles less than 90. And a right triangle has to have a right angle in it. So let's try these. We're going to set them up the same way. We're looking for the biggest side. Well, that's of course 37 or 34. That's A, and that would be B. A and B really don't matter. Which is which? But the C does matter. C has to be the longest side. So we're going to use C squared, and we're going to compare. We're going to use a big circle because we're going to compare A squared plus B squared. So 34 squared, and we're going to compare that with 16 squared and 30 squared. So we're going to get 1156, and we're still comparing that with 256 and 900. So in this case, 1156 is going to equal 1156. Hey, they're the same numbers. So what type of triangle do we have? This gives us a right triangle. So let's try this one. This is your largest number. This is very close to the number 4. It's probably a little bit less than the number 4 because the square root of 4, this is square root of 3, so it's smaller. Square root of 4 would be 2, and 2 times 2 is 4. But this is smaller than 2, so their product is smaller than 4. So we know this is the smallest number. I'll call it A, and I'll call this one B. It doesn't really matter which of those two but we know this is definitely smaller than 9. So we're going to say c squared and compare that with a squared plus b squared. Plug our number in. So we plugged our c, the a, and the b into our formula. We're comparing these. That's what that big circle means. Compare. We don't know if it's equal. We don't know if it's less than. So we're going to put our Pac-Man sign in there if it's not equal. Over here it was equal. Well, this is 81. We're still comparing. How do you square something with the square root inside of it? Think about this. This will get confusing for some of you. You would square the 2. What does that give us? 2 squared is 4 times, how do we square a square root? It'll be the number inside. When you square square roots, you get what's inside. So this is 81 compared to 12 plus 36. So 81 is greater than 48. If 81 is greater than 48, then what type of triangle does this have to make? This has to make an obtuse triangle. And our last one. This number here, it's bigger than the square root of 36. If this was 36, square root of 36 is 6. 2 times 6 is 12. This number is bigger than 12. It's bigger than 10. So we know that's the longest side. So we're going to call that C. That'll be B, and our smallest side will be A. The A and the B really don't matter. So we'll take our C squared, 2 root 41, and we have to square that, use parentheses. Compare that with 8 squared plus 10 squared. Now, how do we square here? How do you square 2 root 41? Square the 2 and square the square root. When you square the square root, you get the number that's inside. So this comes out to be 164. This one comes out to be 164. Hey, we have a right triangle, because the sides work out perfectly. So I want to try to show you something. If we have 3 side lengths, what type of triangle does this possibly make? There's only one triangle we can make with it. And if you look, we have an obtuse angle there, an angle bigger than 90 degrees. So that means that this length squared is greater than those 2 lengths squared. But if I throw in another side, I replace it, now I have 3 angles that are less than 90. So my longest side squared is shorter, or is less than, a squared plus b squared. So that's what you're calculating. That's what you're trying to decide.